Hello everyone, here is another brilliant question. There is a body which is moving in anti-clockwise direction on a circle of radius 5 meter. So let's bring the circle here on the screen. Suppose we consider this is the circle. The center of the circle is at the origin. So if we consider this to be the center of the circle, we mark here 0, 0 and the circle lies in the xy plane. So here in this direction you can show the unit vector I cap, or you can write x here. Similarly, in this direction you can show y, or you can write here the j cap. The radius of this circle is 5 meters, so this is 5 meter, this distance is also 5 meter, this distance is also 5 meter. In a certain interval of time, the displacement of the body is observed to be 6 meter in the positive y direction. Then which of the following option is true? Actually only one option is correct, so we'll check each option one by one. First option says initial position is 5 meter I cap. 5 meter I cap means initially particle was here and it has to move anti-clockwise, so particle will go like this. If particle was initially here and particle goes anti-clockwise like this and reaches up to here, even then its displacement in the y direction would only be 5 meter. But we require the displacement in y direction to be 6 meter. It means this cannot be the correct option. It vanishes. Okay. Now look at the second option. It says initial position is minus 3 I cap plus 4 j cap meter. Minus 3 I cap means this distance along the minus I cap is 3 meter, and this distance is actually 4 meter along the positive j cap, along the positive y axis. This distance is 4 meter, and by Pythagoras theorem 3 square plus 4 square under the root will give you this length 5. Anyways, so particle is here in the second option and it has to again go anti-clockwise. Now check it. What would be the displacement of the particle? If particle goes down like this and let's say particle reaches somewhere here, then its displacement would be directed from initial position to final position like this in y direction. And that displacement is negative. We require displacement along the positive y direction. Here we get the displacement along the negative y direction. It means this is also wrong. This could not be a correct option. Even from here, let's say the particle reaches here or here, in all these cases, the displacement along the y-axis will be in the negative y direction, which is not the requirement of this question. Now checking the third option. Its final position is 4 I cap plus 3 j cap meter. 4 I cap plus 3 j cap, let's draw it with a different color. Let us consider this distance to be 4 meter. This distance we consider as 3 meter. The final position is given as 4 I cap and 3 j cap. So let's say this is the final position. If this is the final position, we can draw the initial position like this here. Let's say this is the initial position. In this initial position, again, this gap is 3 meter. This is 4 meter, this radius is 5 meter, this radius is 5 meter. If this is the initial position of the particle and it moves anti-clockwise, then particle finally reaches here, and check what is the displacement of the particle in the y direction. The displacement is always directed from initial position to final position, and then it would be 6 meter. And we required the 6 meter displacement in the positive y direction. It means this should be the initial position, this should be the final position. So the third option is absolutely correct. And fourth option is anyhow absurd. 6 j cap is not feasible. The highest the particle can achieve is the 5 j cap. So 6 j cap is anyhow not feasible. So this option is wrong. I hope you enjoyed this solution. If you enjoyed it, please like this video, share it with your friends and kindly subscribe to this channel. Stay awesome and thank you.